Hello everyone, this is Mr. Mitchell. We're going to be starting today on slope-intercept form. First thing you need to know about slope-intercept form is the actual form of slope-intercept form. So let's get that on there first. Slope-intercept form is really an equation, and it's always written the same way. It's always written as y equals mx plus b. So that's the first thing you need to know about slope-intercept form, is what it's supposed to look like. When we deal with slope-intercept form, we are actually only looking to replace two of those variables. So we're going to talk about those variables really quickly, and then we'll see how this relates to an actual line, which we have on our graph. The first variable that we look at when we are dealing with slope-intercept form is the variable b. In the slope-intercept form, the b always refers to the y-intercept. So when we look at the y-intercept of our line on this particular graph, we look for where this line crosses the y-axis. Okay? So the first thing we need to remember is that the y-axis is right here. It's the vertical axis, the one that goes up and down. And our slope, or rather our y-intercept, is where our line crosses that axis. So if we're looking at our graph right here, there's where it crosses the y-axis. So our y-intercept in this case is the positive value of 4. So in this case, the b equals 4. The second part of the slope-intercept form is the slope of the line, and that's represented by the variable m. So let's write that down. M is equal to the slope. Now when we talk about slope, and we're going to talk about this a lot over the next few days, but just as an introduction, the slope is basically the calculation of how steep a line is. And the way that we show that is by using a fraction where the numerator is the change in y, okay, specifically meaning how far up and down do we move from one point to another, and the denominator is the change in x, and that obviously would mean how far do we move from side to side as our value changes. So what we do to calculate this is we look at first two different points on the line, and it's always easier if you can pick 2 points that intersect at an actual coordinate. So we're going to look at a point right here, and we're also going to use this point up here. So our first point, the coordinates were 2, 5. And our second point, the coordinates were at 6, 7. Okay, so the next thing that we would do is we have to actually count how far did we change on our y value, or how far up or down did we move from one point to the next. And it's very simple. All we do is we start at the point on the left, and we move, in this case, up 2 spaces, because that's what value we are now on to match that second point. So our first change was a change of positive 2, and that's our change in y. We moved up 2 spaces. The next part is the change in x. So from that end where we just left off, we're now going to count to the right to get to our second point. And if we do that, we end up moving 4 spaces. So our change in x is a positive 4. We moved 4 spaces to the right, and if you look down at the x-axis, as you move to the right, you're increasing in value, so it's a movement of positive 4. So that would be our slope. But just like with any slope, or any fraction rather, we always have to simplify. So what can we simplify 2/4 to turn into, or what does it become? Hopefully, you realize that we can divide both of those by 2, and we end up with 1/2. So our slope in this case is 1/2, and the intercept, the y-intercept, is positive 4. So if we were to rewrite this equation and substitute in the values that we just got, then the slope-intercept form would look like this. Y equals 1/2 x plus 4. Remember that the 1/2 represents the slope of the line, the change in y and the change in x, and the 4 represents the y-intercept, which is where the line crosses the y-axis. Hope that helps. I'll see you guys tomorrow.